we go. Thank you all.
No problem.
Here we are at Chapter 21, Test Hints, Part 2, 20 through 40. And we got a little bit further in the first half, but I may edit that out because I messed up one of them. People in 6th period, I messed up one of them, so I'm going to go over it again here so that you get the right stuff. Sorry about that. Okay, good thing we caught that before you all put down the wrong answer. Alrighty, number 20 is asking about the 3 specific parent nuclides. And there is something posted on Moodle that talks about the 3 common decay series. And one most common parent nuclide is uranium-238. We have a whole series of decays that it goes through to turn eventually into some smaller, more stable nucleus. Okay? What is another one of the parent nuclides? You worked with it in the simulation in your nuclear processes.
Polonium.
No, that's not one of the parent ones that we did. And the one that goes through the whole decay chain. We looked at that as an individual element, but it doesn't go through the whole decay series.
I'm not quite sure about this, but U-239.
Oh, U-239 is a good example, but that one actually gobbles up a neutron and is stable. It's U-235. Uranium-235. That's the one you spent the most time with. Okay? And there's another one. Abby?
TH-232.
TH, thorium-232. Okay, those are the common ones. They are parent nuclides, and they go through a decay series, which answers number 20, or helps you with 21. And these decay series end up in what?
Radon.
What kind of nuclide is left at the end? If these are the parents, the daughter nuclides at the end. Okay? Now, what is an element that's probably not going to be a parent nuclide? Because many of these things decay into it.
He42.
Oh, they don't go all the way down to that.
Lead.
Lead. Yeah. Isotopes of lead. All right. So that was 2021. 22. What is required in order to do artificial transmutations? Artificial transmutations. Well, for one thing, they're going to take an awful lot of what? Energy. An awful lot of energy. And some sort of particle or something, right?
Correct.
Okay, like a what?
Neutron.
Like an alpha particle or a neutron, something like that. 23. How artificial radioactive isotopes can be prepared. So we can, this kind of is a takeoff of the one we just talked about. We can bombard them with alpha particles, neutrons, what else? What else?
I can't see that far.
Can we shoot protons at them? Yeah, we can, for some of them. How about neutrons?
Positrons.
Positrons, yeah. Okay. So several different things. 24. How magnetic fields affect each of the common types of nuclear radiation. This is the one I goofed up.
Oh.
Oops. Okay. What are our common types of radiation? Let's just jot those down.
Gamma.
Gamma. How is a magnetic field going to affect gamma radiation?
It doesn't.
It's not, because it's energy. What is another common type?
Non-existent.
Alpha.
An alpha particle. How is a magnetic field going to affect an alpha particle? What's it going to do to it? What's it going to do to the alpha particle's path?
Change it.
Screwed up.
Bend it.
Change it, bend it a bit. How, and what's our other kind of common particle?
Bend
Beta. And what is the magnetic field going to do to a beta particle?
it. Track
A
it.
beta particle's path.
Nothing.
Oh no, it does something.
Screwed up. Blocks it.
Reflects
Doesn't
it.
block it. It's going to bend it as well. Which one is going to be bent or deflected the most?
Gamma.
No, gamma's just energy. Gamma energy's not affected by the.
Alpha.
Are the heavier, slower ones or the lighter ones going to be more affected?
Beta.
Lighter ones. The lighter ones are affected. That's the part I messed up. Sorry, 6th period. Lighter ones.
So which one's a lighter?
Which one's lighter? What?
Beta.
Yes.
Good job.
Let's see. Where are we? 25? Boy, 25. How do the speeds of each of these compare? So which is fastest?
Alpha.
Beta.
Gamma. Which is slowest? Alpha. Which is mediumest?
The whiteboard.
Beta.
Beta. Okay. Boys, are we focusing? We're on the World Wide Web here.
He's telling me to mess up the recording.
What?
He wants me to fake a sneeze.
Mess up the recording. I think we just did. Okay. 26. How the penetrating ability of each of these types of radiation compares. Which one penetrates the furthest or most? Gamma. Which is the least?
Alpha.
Alpha. What stops alpha?
Skin.
Skin, paper, plastic. How about beta?
Oil.
Tinfoil.
Foil or
Water.
water or lead. Lead will eventually stop gamma.
Lead concrete.
Concrete. Yes.
The center of the universe.
The center of the universe. Okay. 27. What units measure radiation? It is named after the guy who discovered or made the X-ray, made the first X-ray machine.
AMU. Malcolm X.
Not AMU, not Malcolm X,
Geiger.
Hans Geiger.
not Hans Geiger. He made the Geiger
Han
counter.
Solo.
Rutherford.
Not Han Solo.
Pennsylvania.
No,
Alpha.
not Brown, but I bet there's a big hint in the next test. Hint. Röntgen. Wilhelm Röntgen made the first X-ray machine, and the first X-ray, I think there's a picture in your book. First X-ray developed was a picture of his wife's hand with her.
I remember that.
Yes. So we measure radiation in Röntgens. Röntgens. R-O-E-N-T. You say like.
We don't even know that.
You pronounce row, but say E. Röntgens. That's gonna look attractive. 28. How REMs compare to Röntgens? Oh, they do. What does REM stand for? Not rapid eye movement. And not a band from the 90s.
The band.
Gonna answer some REM.
Put out and then Röntgen
Not exactly.
It's debatable.
What does REM stand for? Something equivalent.
Rest in peace.
Radiation.
Röntgen equivalent.
Magnetic field.
Man. Okay. So, one depends on the other. Okay? Not to be confused with the RAD, which is the radiation absorbed dose. We'll talk about that in the, well, you've seen that in the PowerPoint if you looked at it. 29. What devices are used to detect radiation? Now, this is something you were getting from your book. We used a Geiger counter in class.
Awesome auger.
So, we have a Geiger counter. And I've been asking you to bring your book for the last 2 weeks. A scintillation counter, yes.
Clutch.
Scintillation counter. And what are scintillations? Goodness, what a weird word that is. Scintillations, anybody know?
Instruments that convert scintillated light to an electric signal for detecting radiation.
Yes, converting light to an electric signal. They're little flashes of light. Little flashes of light.
Photons.
Kind of. And
Was that
what do they use in hospitals or nuclear submarines? My brother wore one on the sub.
Radiation suit.
Kevlar. Gamma rays.
How about a film badge? No, they don't wear gamma rays.